Find all points of discontinuity of f for the given function. Solution: to check continuity, we have to show that limit x tends to a minus fx is equal to limit x tends to a plus equals fa. So firstly check at x equals minus 3. Now we start with limit x tends to minus 3 minus. As we are given in our equation that for x less than equal to minus 3 we have to take function modulus of x plus 3. After that we replace modulus of x with minus x. Because if we put values that are less than minus 3 we got our negative answer. Now put our limit that is minus 3 in place of x. From which we get our answer 6. Remember that when we fill our limit, don't write limit function at that time. Now we solve for limit x tends to minus 3 plus. So we are given with function minus 2x if x greater than minus 3. Now put limit that is minus 3 in place of x. From which we get our answer 6. Now we have to check at exactly x equals minus 3. Again in equation for x equals minus 3 our function is modulus of x plus 3. Put value of x and we get answer 6. So therefore all the answers are same. So f is continuous at x equals minus 3. Now we have to solve for another limit that is at x equals 3. So firstly we solve for limit x tends to 3 minus. For less than 3 we have to take function minus 2x. Then put limit in place of x. From which we get our answer minus 6. Now solve for limit x tends to 3 plus. According to statement for x greater than 3 we have to take function 6x plus 2. Then fill limit and we get answer 20. As answers are not same. So f is discontinuous at x equals 3. Now we are given with an equation. And we have to find points of discontinuity. So we know about the definition of continuity. Here there is only one point that is 0. Firstly we start with x tends to 0 minus. We know that for less than 0 we have to take function sin x over x. As it is not a polynomial. So we change our method. Put x equals 0 h where h is greater than 0. And our new limits become h tends to 0. Now this function is equal to 1. According to the formula. Now start with x tends to 0 plus. For x greater than 0 our function will be x plus 1. Again apply same formula and our limits changes to h tends to 0. Then put 0 in place of h and we get answer 1. Now solve at exact x equals 0. For x equals 0 our function is again x plus 1 from which we get answer 1. Therefore all the three answers are same. So f is continuate at x equals 0. So there is no point of discontinuity. Which is the answer?